given a string S, return true if it is a palindrome. Otherwise, return false. A palindrome is a string that reads the same forward and backward. It also is case insensitive and ignores all alphanumerical characters. Was it a car or a cat I saw? Is true. Was it a car? That's crazy. This entire sentence is a palindrome. But what category is this problem in? 2 pointers. Okay. Not very familiar with the 2 pointers category. But is valid palindrome. We've got to I guess we create 2 pointers, one at the beginning of the sentence and one at the end, and we just go into the middle. Oh, we also need a base case. So a base case, if the string is odd. What happens if it's odd? Tab a cat is not a palindrome, correct? Let's look. What are the examples? Oh, the examples are probably, yeah, the same ones. All right, so case insensitive and ignores all alphanumeric characters. Okay, so basically we need to clean the string up. We need to remove all the spaces and alphanumeric characters. So we'll start in Java. What would the time complexity be of this? I think we could just do it in O of n time, because we'll just have one for loop that's and make the pointer start from the beginning and have a pointer that starts from the end. So for int I equals 0, I is less than s dot length I plus plus. And so, oh wait, this should be s dot length divided by 2 actually. Because we're starting at both ends of the string, so we're starting at both ends of the string, so on this end, it starts at I, and on this end, it'll start at s dot length minus I. S dot length minus 1 minus I. Because s dot length is the entire length, we want the last character, which is s dot length minus 1. So if, also this is going to be after the string is cleaned up. So if s I is unequal to s I s dot length, let's just calculate the length of the string once int size equals s dot length. And we'll replace that there, and we'll replace that here. So minus 1 minus I. Then we return false. Otherwise, return true. Cool. So now we need to ignore the alphanumeric characters and spaces, which I'm not exactly sure how to do. How to remove alphanumeric characters in Java. How to keep only. Okay, there's some regular expression. All right. So we'll make s equals, no, we want to do a copy. String copy equals s dot replace all. All right, and let's just print this to see, make sure we're getting what we think we're getting. Oh, is this a compilation error? Array required but string found. Okay, I guess we'll use s dot char at I, and we'll replace that with that here, s dot char at. Okay, so we got a wrong answer in case 1. Oh, we also want to lowercase. Silly me. Equals dot to lowercase. I'm pretty sure that's a function in Java. Yes, that worked. That made the string only alphanumeric. And lowercase. Case 2 passes. We get false. But for case 1, let's, I guess this calls for some print statements. Let's see what characters are being compared. System dot print line s dot char at I plus empty string plus s dot char at size minus 1 minus I. Okay, now this will show us what 2 characters are being compared. Whoa. Oh, I forgot to replace this with the copy. Now this should run successfully. No. Oh my gosh. I have to recalculate the size. So I'll remove this. I'll remove this print statement as well. And I'll move this size variable to after we make the copy, and I will make it the size of the copy instead of the size of the default string. And both cases pass. And we did it in O of n time because we have one for loop that goes through the whole string. So let's see what the recommended time and space complexity is. You should aim for a solution with O of n time and O1 space, where n is the length of the input string. O1 space. Well, this uses O of n. Wait, no, it doesn't use. It just yeah, it uses O of 1 space because the size variable. Oh, wait a second. No, we store the string. We store a copy of the string, so I think this means it uses O of n space. A way to do this would be to have a check in the for loop if character is in this, if the character is alphanumeric, then continue. But that would throw off if there's multiple spaces in between here or there. All right, let's submit this. All right, let's check out what the solutions are. Reverse string is palindrome. Use string builder to build a new string. For character C and S to car array if the character is letter or digit. Whoa, I didn't know this was a function. Okay, so in the two-pointer solution, we have L, and it's set to 0. And we have R, which is set to the last character of the string. And so while L is less than R, and alpha num. Okay, they define this function alpha num. It takes in a character, and it returns if the character is alphanumerical. Okay, so while L is less than R and the character is not alphanumerical, we increment the counter. All right. Also, while R is greater than L, and it's not. Okay, so R starts at the end of the string, L starts at the beginning of the string. If the character is not alphanumerical, the algorithm skips that character. If character dot to lowercase. Okay. So they convert the characters to lowercase and they compare them. If they're unequal, then you return false. And then you increment and decrement the counter. If you go through all that, return true. So yeah, this doesn't require any string storing. But this does all the calculations of whether that string is alphanumerical and lowercase. Okay, that makes sense. We'll I'm gonna implement this solution in C++ without looking at it though. So we need two counters, a beginning counter and an end counter. So start that here. Int start equals 0, int end equals s dot size minus 1. Then we have a while start is less than, while start is less than end, we want to also see while start is less than end and the character needs to be, so if it's not alphanumerical, okay, we'll also need to define a function. Bool is alphanumerical. It'll take in a character, char c. We need to return a Boolean, true or false, based on whether the character is alphanumerical. So to do that, if C is greater than A, that's not a car, this is a car. If C is greater than A, and C is less than uppercase Z, return true. This is going to look a little bit more complicated than the one in the Java code solution because I want to spell it out and have it all readable. The other one wasn't as readable. So we've done A through the Z. Now we want lowercase a through Z. So if C is greater than A and C is less than Z, then we also return true. And now we want the numbers. So if C is greater than 0 and C is less than 9, return true. And now if none of those cases execute, then we want to return false because we haven't returned yet. And not is alpha numerical S. Okay. I'm confused now. So we need to see if both of the characters, the start character and the end character, are alphanumerical. So all right, let's remove this and start thinking about it a little more. So I'll use this handy Microsoft Paint online. So we've got the word 1, 2, 3, 4. 1, 2, 3, 4, 5. All right. So this will be, all right, A, T, T, A, question mark. So the end starts here. Boom. Beginning is here. When we want, we're in the while loop. While the start is less than end. Yep. We want to see if this is alphanumeric. It is. then go to the comparison. Is this alphanumeric? It's not, so move the counter, or the pointer down. So I'm thinking while s start while not is alpha numerical, s start start plus plus, and then another while loop. While not is alpha numerical, s end and we decrement the end, so end minus minus. Then okay, now we can compare. I don't know if there's a 2 lowercase in C, so I'll have to check that out. 2 lowercase C++. Okay, there's a .to lower function. If to lower string start is n equal to lower s end, return false. Otherwise, you return true. Now, I'm sure there's going to be some compilation errors here. Yes was not declared in the scope. True, I need to put you up top so that you will be declared in the scope correctly. Public, here we go. Boom. Also shift tab this over so it's correctly indented. There we go. Oh, there's double equals there. This is a symptom of my extensive experience in JavaScript. It's a habit. Time limit. Uh-oh. I have a infinite loop. So interesting. So we have an infinite loop. we have two while loops and an outer while loop. So we check if the string is alphanumerical, then we skip over this. If the character is alphanumerical, we skip over this. And we check. Is it unequal to the character at the end? If it is, we return false. So somewhere there is an infinite loop, and I'm not sure why. So we initialize the start to 0. Let's go through this test case right here. Okay, we initialize end to the last character position of the string. While start is less than end, which 0 is less than the size, it's less than 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's say 21. While 0 is less than 21, correct? Okay, while is alphanumerical S start. S start is W. Is it alphanumerical? True. That should skip. You know what? Let me just test my function. My is alphanumerical function. So we'll print to cout, and we'll just do is alphanumerical S start, and then we'll also print out if the last character in the string is alphanumerical. So an empty string is for some readability, and is alphanumerical. Oh. Is alphanumerical and the end of the string. Let's see if that function works. One false. Okay. Okay, so through extensive testing of the alphanumerical function, we know that it works. So, why is it still not working? Well, we haven't changed anything since. We get an infinite loop. Yippee! Yeah. While okay, f2 lowercase is unequal to 2 lowercase of the last character, and return false. Oh, I know why. Because we don't increment and decrement after. Silly me. Start plus plus and minus minus. Okay. Now we will see. Oh, let's go. It passes. Both cases. So yeah, I forgot to add these 2 lines. It would just repeat the same. That's why there was an infinite loop. So we passed those 2 cases. Submit. Wrong answer. Oh, so the is alphanumeric function doesn't work. Or does it? Your output false. So for this test case, it's A period. Our start is at 0. Damn, yeah. That's right, Lord McCarl. And our end is this character. While start is less than end, correct. While not is alphanumeric character. This doesn't execute because this is alphanumeric. Then while is not is alphanumerical end minus minus. So it should decrement at this point if this function works correctly. And then so they're both equal to 0. So if to lower start is unequal to lower end, which it should be this pointing to the same place. So this shouldn't execute. And then it increments the start. Then the start is 1. And end is -1. So start is 1 and end is -1. Start is less than, which is greater, so it should break out of the loop. So that's probably why. So this we should probably print what happens when is alphanumerical gets a period character. So just to confirm, just for a little sanity check, it's good to confirm sanity every now and then. So false is alphanumerical. It executes. So this function works correctly when we get a period. So that means I'm stumped. You know what? Let's also print while we go through the loop. To lower s start and to lower s end. Okay, why are these different characters? What is ASCII code 109? It doesn't tell me. It's a lowercase m. Where the heck is M? Where do they get M from? What's ASCII code 113? .113 is Q. What? How the... Bruh. What is going on? What? Why do I get an M and a Q? Nine and negative 24? If that was the case, then shouldn't this be out of bounds? Shouldn't I be getting an out of bounds error if start is at 9 and end is negative 24? This shouldn't be this complicated. Alphanumerical returns false when given this character. You know what? What happens when I pass in that character? Maybe there's different functionality. So let's print is alpha numerical given s end. False. Correct. Yeah, that's what we want. And then we want it to skip down. So it end equals 0. We want n to equal 0. So then S0 is compared to S0, and this shouldn't return start plus plus makes start 1, and minus minus makes end negative 1. Start is 1, negative 1. 1 is less than negative 1. That's false. So we break out and we should return true. But that's not what... That is not what's happening for some reason. Because... Oh nice, I can use the test case here. I can also create my own test cases. Nope. Run. Okay. We'll also print here the lower to lower. You know what, let's print out start, and we'll print out end. It should both be 0. Oh, forgot the semicolon. They're not the same. They're not 0. None of them are 0. What? That's so weird. What the hell? Let's print out is alpha numerical s start. Oh, I print out if end is. I want to see if start is alphanumerical. We'll print a new line for readability. Is alphanumerical start is false? Why is that happening? Why is lowercase a not alphanumerical? Let's print out start. Is it getting the right character? Colon. Case 3. Okay. Start is 0. Is alphanumerical. S start. False. Oh my god. This is ridiculous and embarrassing. This should be greater than or equal to. Less than or equal to. Because these are valid characters. Lowercase a isn't a valid character according to my code, but now it is. Success. Okay. That was a silly bug, but we figured it out. And it only took 35 minutes. Oh, man. Submit. Wrong answer. Let's go, dude. It should return false. No, it should return... This string should return true? It's true. But we get false. Alright, so let's see why. Okay. Yeah, I guess it's expected for start is not alphanumeric, so it increments. And it increments again. And also, end is not alphanumeric. Again, so n should be -1 at this point, and start should be 2. Yeah, we shouldn't be getting to this point yet. But we are. Interesting. We need some more prints. We need to understand why. So let's print out start and end at this point after the while loops have executed. And we'll make an end, just so we know. Just it's nice, just so it's nice and readable. I used a plus. It needs to be a angle, brackets like that. Let's add this case to our test cases, and we'll run it. Okay, so start is 57, end is -24. That's probably in some, that's probably ASCII code or something. I don't know why it's, maybe it's trying to convert to the string. So what if we just print it like that? Is it still -57? It's still 57. Okay, but if it was 57, okay, why is it actually 57? If we print out high each time, then we should get 57 highs. Do we get 57 highs? Oh my gosh, we get too many highs. We get too many highs. We shouldn't be getting that many highs. We should also be checking if start is less than end. And for this as well, while start is less than end, and okay, now let's see if this test case passes. Oh, sweet, it passes. All right. We've successfully solved the problem. That was kind of redundant. I didn't need to say successfully solved. I could have just said solved. But we have solved the problem in C++, and this is using the O of n execution time and O of 1 space complexity, because we do not create a new string and store it in memory. We just go through, while we go through each character in the string, we check if it's alphanumerical, and then we convert it to lowercase to do the comparison. So let's go. Thank you, my Carl. Let's go. Now we can solve it in C#, baby. C#. Ugh. I don't like C#, but well, let's get it. So we'll do it in the time complexity, just like O of n time complexity, O of 1 space complexity. So we'll just be using the same solution, but with C#. So int start equals 0. Int end. The size of a string in C#, I'm not familiar with it. So I'm just going to say it's s.size, like that. I could be getting a compilation error down the road, but we'll see. Also, this needs to be -1 because we want the last character. We don't want an out of bounds. Okay, now we want our while loop that goes through the string. So while our start is less than our end, we want to check if the string is alphanumeric. Well, I mean the character is alphanumeric. My apologies. While. And don't forget, the thing that was messing us up was we weren't checking if the start is less than the end. If that's the case, I mean, the start needs to be less than the end for us to check if it's alphanumerical. Also, let's just write our function. So we'll make it private because we just want it accessed within this class. Private bool is alphanumerical. And we'll take in a character C. And so we'll do our checks again. So if, oh, and this time we won't forget to check if it's equal to as well. So if C is less than or equal to A, and C is greater than, you know what, we'll do greater than or equal to A. So we'll return true. Or if C is less than or equal to Z, return true. We could also just do this in one return statement and it'd be easy, but this makes it a little more readable. So if C is greater than or equal to, oh, also, I forget the convention, but I think that needs to be like that. Because a character, at least in C, is in single quotes. I'm not exactly sure what it is for C#, but it's just a Google search away. And C is less than or equal to Z. And now numbers. And C is less than or equal to, whoops, 9. Return true. Otherwise, we return false. All right, here we can increment start if there's a it encounters a non-alphanumeric character. So not if it's not alphanumerical, s dot car at start, then we just want to increment start. And then we have our loop that checks at the end character. So, and not is alpha numerical s dot car at end. Then we decrement the end pointer. Okay, perfect. Now this is where we check if, also it needs to be lowercase. I'll assume the function for lowercase in C# is the same as the one in Java. So s dot car at start dot to lowercase if it's unequal to the character at the end in lowercase, then we return false. If it isn't, then we go to the next. Don't forget to increment and decrement your pointers, because then if you do, you'll get an infinite loop. And so if we've gone through the whole string, then we can return true, as we haven't returned false. We haven't come across a character that is unequal to the mirrored character. So let's run this in C#. We have a compilation error, as expected, because size is not a thing in C#. Is it dot length? Don't tell me it's dot count, because it can be dot count. Let's just see if it's that. If it is, I'm gonna throw up. Okay, all right, good. Wait. Oh my God. It is dot counts. Disgusting. I don't like C#. That's ridiculous. Okay, operator cannot be applied to operands of type method group. String does not contain a definition for char at. Okay. Get character from string C#. Okay. Is it just... Oh, it's just, oh, I like that, actually. C#, that's not bad. I like that, dude. So if it's just like this... Okay. If it's that like that, then I like that. I like accessing characters like that. I feel like that's such a nice way. Because if you think about it, a string is really just an array of characters. Alright, so now we've fixed that. Does that work? So that's bonus points for C#. Car does not... Okay. 2 lowercase car. C#. It's just 2 dot... It's just dot 2 lower. Okay. That's the thing with C# that I'm not a big fan of. They start the function names with a capital. Instead of camel case. Alright, that's the correct function for a lowercase character. Oh. Interesting. Dot 2 lower. No overload method for method 2 lower takes 0 arguments. Whoopsies. I mean, I don't pass any arguments into 2 lower. I call it on a character. It needs to be car.toLower. And I have to pass in this. See, now that's silly. That's silly. I don't like that. The bonus points that C# won with the accessing the characters in the string with the flat brackets, it lost those points for me having to do this. Operator minus cannot be applied to operands of type method group. Okay, so operator minus cannot be applied to operands of type method group. Okay, so maybe this isn't the right. Let's see, length of string C#. Oh, it's dot length. Okay. Easy. Easy peasy. But it's with the capital at the beginning. I find that off-putting. Alright, so 3 test cases solved. Let's submit it. Svelte. Have you heard of Svelte, Lord my Carl? Is that one of your random programming terms you know? Let's go. Solved in C#. Interesting name. It is an interesting name.